For part B, we're being asked to find f prime of -3. It'll look just like the last example with -3 in place of +2. So it'll be the limit as h goes to 0 of f of -3 plus h minus f of -3 all over h. And this is simply an instruction for me to take -3 plus h and plug it into the function, take -3 and plug it into the function, and make sure that I subtract that entire quantity. I'm going to pause the video and do the math separately, so feel free to pause it if you want to try and work ahead of me a little bit. Also, if you feel after this example you've got it, I do want you to watch the next example, and then the next one after that. I'm going to show you a shortcut of doing the algebra because I'm not too worried about the algebra and I'm going to save you some time. But I do want you to do this one all by hand. I'm going to pause the video now. So this is me just taking the -3 plus h and plugging it into f. So this portion is just handling this part of the definition. I'm going to pause the video again and write down what happens with this part. I'm not going to simplify things down all the way because I don't want to use that much brain power. I'm just going to write it out. Here I go to pause. So you'll notice that I've taken -3 and I've plugged it into that function. I put a big parenthesis around the whole thing to make sure that this negative sign gets distributed to both parts of that function. This entire thing is all over h. And if I were in high school, I'd lose a point right now because I forgot to write this limit as h goes to 0 in front of the quotient, which is something technically that you should, do. Now I'm going to go ahead and simplify these things. I'm going to FOIL this out using shortcuts that I remember from Algebra 2, distribute this stuff. I'll simplify some of these numbers, but not all of them. Pause the video right now to do that. So taking -3 plus h and squaring it, I'm using that old trick about squaring a binomial where you square the first term and you square the last term and you multiply those together and double it, or you can FOIL it out. But this whole piece is -3 plus h squared. This is me taking this -3 and distributing it to the -3 here in the h, and then I have subtract -3 squared is 9, and then we have a positive 9. Now I'm going to start to, hopefully things will cancel. I'll distribute this negative to both of these, but I'm going to again pause, erase all this, and recopy this expression where I have more room to work. When it's all said and done, we'll see if we're on the same page. You might want to pause and do that work as well. I'm going to pause right now. So this is that same expression, just with the parentheses removed and minus signs distributed. I'm not combining like terms because I'm trying to find, this is something you guys aren't used to, and you don't have to do it the way I'm showing you right here, but some of you might consider trying to see how it plays out, not actually combining terms, but just leaving them as they are. It does turn out that this 9 and this 9 cancel, this 9 and this 9 cancel, leaving us with, and these guys will combine. So we're going to be left with the limit as h goes to 0 of h squared minus 3h all over h. And you can just, if you understand this part, you can just cancel an h off of each of these, giving you h minus 3. But if you don't know where I'm getting that from, on the numerator here, there's a common factor of h. I can factor that out. So that'll make the limit as h goes to 0, h times quantity h minus 3 all over h. These can cancel off, giving me the limit as h goes to 0 of h minus 3. Now I can plug 0 in for h, and I won't get 0 over 0. I'll just get a -3. And that tells me that f prime of -3 happens to also equal -3. And if I wanted to verify that, I could look at this guy's graph, zoom in really close on -3, and see that the line that appears, like the thing that looks like a line, looks like it has a slope of -3. The next example takes the same idea but replaces the 3 with an x, and we get a function instead of just an answer. And so please watch that video, and then watch the next one because I'm going to give you guys a shortcut for avoiding all the nasty-tron algebra, like the squaring and cubing of binomials. You're going to want to check it out. All right, I'll see you guys in the next video.